Hello and welcome back. And in this video and following a few videos, we're going to be talking about LazyVStack. So a VStack is a container view in SwiftUI that arranges its child views in a vertical stack. We already know that. Now, right one after that is basically a LazyVStack. Now, LazyVStack is a variation of a VStack, but it is significantly different from the way it actually works. LazyVStack basically loads its children or child views as user scrolls through them. Now, this is especially useful when you have a large number of child views and the views that basically require to build the UI are rendered dynamically. Okay, that's where LazyVStack comes into basically picture. Now, this is much more efficient because the main difference between VStack and LazyVStack is that the VStack creates all its child views in advance, whereas the LazyVStack only creates views that are currently visible on the screen plus a few more as a caching mechanism, so you don't see them loading as you scroll through the view. The LazyVStack creates a new view and destroys the old one as the user scrolls, and it basically keeps only a small number of views in the memory at a given time, versus on the VStack, which keeps everything in the memory. Okay, so LazyVStack is your classic example of using table views, reusable style. Okay, now LazyVStack is a container view which is used to lay out child views in vertical order, just like VStack. And the lazy keyword distinguishes the VStack from LazyVStack. All the views are rendered in the memory, and in case of VStack, all the views are rendered in the memory as soon as the view is initialized and as soon as the views appear on the screen. LazyVStack takes this basically approach more dynamically and eases the pressure on memory by only rendering the views that are needed to be displayed or needed for the current UI, which is on the screen. All right, so let's go ahead and explore the differences with examples. So we'll create a scroll view and we'll add a VStack inside that. Now this VStack will contain a for each, and we'll create 100 text views. And those text views are going to display current time in seconds, and current time basically to the second, so you can see the difference. And in order to get time from date object, we'll create an instance of date formatter and pass it in the formatter property for the text view. Okay, so let's go ahead and take a look at an example. We're going to create our example 1. Let's go ahead and create our date formatter first. We're going to create date formatter object as a computed property, and inside the computed property, we're going to create our formatter object. Let's go ahead and return the formatter. And then we're going to say formatter.date format is going to be hours, minutes, seconds, and Z, I believe, is for the time zone. All right, so we have basically our date formatter ready, and then we're going to create our view. Like I said, we're going to start with a scroll view. Inside the scroll view, we're going to create our VStack first. And inside the VStack, we're going to create a for each, which is going to iterate over 1 to 100 numbers ID'd by self. What we get is basically an index, but we don't care about that index because we are going to be using a text and the date. So we're going to simply say _in, and we're going to say text, which displays a date. And under the formatter option for the text view, we're going to pass our date formatter. Okay, let's go ahead and call this in our LazyVStack view example, and I'm gonna reload the preview. All right, so our preview is loaded. Let me zoom in a little bit, and one thing you would notice is that we have actually, let's do small z, because small z would actually print the actual time zone. Okay, all right, so as you can see, basically we have a list of all the text views, and notice that all the text views have the seconds listed as same. This actually proves the idea, or like, you know, the concept that we talked about, where VStack renders every single thing at once. Basically, it creates and loads it in the memory and basically just renders it. So basically, you know, what I'm trying to say is VStack can be can create pressure on the memory by loading everything onto the screen. So if you have a lot of content that you want to display on screen, it's better to use LazyVStack. Now, creating LazyVStack is very easy. You just append lazy in front of VStack, and everything else mostly remains the same. Okay, so as you can see, there are, like, you know, a couple of things that have changed. First of all, your views are rendered at dynamically, basically at the time when they were rendered. So for example, all these are, like, you know, 0.6 seconds, but these are 10, and further down they are, like, you know, 15. So this proves that not all the cells have been loaded at the same time, but they were loaded later on as we scroll through the items. Okay, so that's one difference. There is another difference which is pretty significant. The LazyVStack takes the entire width. Basically, it tries to take as much space in the width space as possible. So if you notice, the scroll view is all the way towards the end, and I can actually swipe anywhere to basically scroll this list down. Now if I go back to our VStack, in case of VStack, the VStack, it takes only enough space required in the horizontal direction to render the view. So if I scroll here, nothing happens, but if I scroll here, which is inside the VStack, then only I can actually scroll through the content. All right, so it depends, like, you know, on your use case, how you want to handle it, but you can actually give your VStack the same behavior as LazyVStack by giving a maximum width of infinity, which actually would work fine. Or instead, you can use a LazyVStack, which actually provides that functionality for free. All right, with that, we have reached the end of this video. In the next video, we're going to talk about container spacing a little bit more between VStack and LazyVStack. So I'll see you guys in the next video. Thank you.